Okay, this is a brief video that accompanying the directions that I'm sending you to remind you how we did the SPSS analyses in class the last 2 weeks. Um, so we're actually starting on letter B. What has happened? This is an SPSS file. If we've done the instructions in step A already, where you open up the SPSS program and the dialog box asks you to find an Excel data file, and then you import that in. That step's fairly straightforward. So we're really now have a current SPSS file. Step B, data snooping. So one thing you can do, and most things are in Analyze, is you go up to Analyze, and in this case, Descriptive Statistics, Frequencies. And we'll just, to make it simple, we'll just put a couple of variables over here, like science experiences, science courses, and maybe the first question that we asked on the STEBI. That's Q1, is when they took the STEBI before the test, before the class. And in terms of statistics, you sometimes may be interested in the mean, the median, or the mode. In this case, I'm not, but if I click those, it would give them to me. In fact, I'll just click it to show you. Say I wanted the mean. Continue. And I would like some charts. I like histograms. So we say continue. It's going to give me charts. It's going to give me the mean for the science experiences, the science courses, and how the students answered question 1. It opens up the output window. It gives me some statistics here, just overall that I've got 98 cases, no missing data, and a frequency table. Have you had previous science experiences? Was this variable? 18 students reported no, they had not had any previous science experiences outside of school, and 79 said yes, they had. This is kind of an artifact. One student put something in there that wasn't really a valid response, but anyway, most of the students had some kind of out-of-school science experiences they reported. And as far as science courses, 3 students said they had not had any university-level science courses previous to the science methods courses. 14 said they'd had 1. 1 student said they'd had 12. So you see some students here that had quite a few science courses. And as you'd expect with pre-service elementary, several had only had a few. First question on the STEBI, whatever it was, they're strongly agreeing or disagreeing with it. Just says that 2 students strongly disagreed with that statement, 9 disagreed, 19 strongly agreed. You can see the pictorial. Not very many students had science experiences, or so they said, outside of school. Most had science courses. You can see that the bulk of students had 1, 2, or 3 courses. And a few had none, and a few had several. But most have had 2 or 3 courses, as you can see from the visual. The first question on the STEBI, most were agreeing with it. A few strongly agreed, few were on the fence, few disagreed. That's how you read the output window. In this case, I'm not going to save the output window. I'll hit the close. Do you want to save it? No. And I'm back to my data set. I'll just show you one more to give you the idea. We'll go to C. And I want to see, was there any differences between males and females on their overall confidence prior to the course. So I go to Analyze, Compare Means, and this is an independent samples t-test. I'm comparing males to females. They're independent. Gender is my grouping variable. Defining the groups, I've just defined females as a 1 and males as a 2. Continue. And let's just look at their pre-science self-efficacy and their outcome expectancy. Do they think their teaching will make a difference to student learning? I'll say OK to that. And I get this output. What I'm looking for here, there's group statistics. As always, the computer always tells you the basic information, how many people. There was 81 females, 17 males in this group of students. The means they had for their pre-science teaching self-efficacy, the means they had each for the outcome expectancy. And then what we're really concerned with is the test, and in this case it's a t-test. So here's your t result for self-efficacy, how confident they were to teach. What we're looking for here is the F and the statistic. Actually, I put you into the wrong column. We're looking for the t-test result, which is here, and was it significant? So all you're really looking for here is, did they differ? And you're looking for the significance level. 0.6 is much larger than 0.05, 5%. These are two different tests, not to worry, but either way you look at this, for self-efficacy as well as for the outcome expectancy, these are not significant results. Therefore, males and females did not differ significantly in their overall self-efficacy or their outcome expectancy. So there was no gender difference in the data. Close the output window. I answered the wrong way. Do I want to save it? No. And we're back to where we can analyze differences. So probably the most common one that you'll want to do is D. Did the students, after having taken this methods course, in your case it might be after you've done some special kind of way you want to teach them, did they change in some kind of measure you'll give them before and after? So let's go to Analyze, Compare Means, and this time Paired Sample T-Test. Remember, it's really important that you get some kind of identifier, the children's names or an identification, because when they take the survey or the achievement test before, and then when they take it after you've taught them, you need to be able to compare each student with themselves. That's the only way you can do a paired sample t-test. So let's just look at the most substantive one, their self-efficacy. So I'm going to use their overall self-efficacy after they took the test compared to it before. And this one is pre. And I'll simply say OK. Now I'm looking for the t-test result. There's other things as usual the computer does. What we're concerned with is this t-value and the significance. And that 0.000 is less than 0.05. My conclusion is that the students did increase in their self-efficacy for science teaching after they completed the course. Again, no causality. I can't say that the course caused that change. I can say it contributed to it. It was a factor. And I can say that they definitely left the course feeling more confident about science teaching than before. But you can't do causality outside of a anything but an experimental design. Close that. Don't want to save it. And we're done for now.